Okay, illustrative math, Algebra 2, Unit 3, Lesson 9 is called Solving Radical Equations. All right, our goal is I can solve equations with radicals in them. So it's kind of like backwards, like when we had squared, we had to, I don't know, if I had something like this, x squared equals 16. You square root both sides because you know the square root and the square undo each other. And then we get two answers there. So now it's going to kind of be backwards here. We'll have like maybe square root of x equals 16. Or maybe let's do equals 4. So we're going to square both sides. The square and the radical undo each other. And we get x equals 16. Notice we don't have a plus or minus because I could not plug a negative 16 in for x and get 4. The square root of negative 16 gives you a non-real number. Okay, so if you typed in square root of negative 16 into your calculator, you would get an error. All right, solve these equations mentally. Okay, so go ahead, pause the video. Try to solve these mentally. You're thinking, without algebra. So I'm thinking, okay, what number for x cubed root would equal 1? And I think that's going to be 1 because you kind of think, oh, okay, cubed root of 1 is equal to 1. And this is a radical, and this is a radical, so we want this whole quantity to equal 7. So I think x would have to equal 8 because if I plug in 8 here, 8 minus 1 would mean that radical 7 equals radical 7, and the left side's equal to the right side. So this one I'd have to kind of like say, all right, square root of 100 is 10. So 2x, you could divide each side by 2, or you could just kind of mentally say 2 times 5 would work. So this one's a little tricky because you think that it's 24, but when I do the square root of 25, remember it's not plus or minus 5 here, it's just 5 because the radical was already given to us. If you have to insert your own radical, then you need a plus or minus, kind of like I did here when I had to insert my, in this one, when I had to insert my own radical, I needed the plus or minus. But this one, the radical was already there, so this denotes that we want the positive root, the positive square root, so we would just have 5. 5 is not equal to negative 5. So I don't think there's any way we could take a square root and get a negative because the square root is already there, so we want this quantity to be positive, so this one would probably be a no solution. So hopefully you figured that out on your own when you pause the video. If not, now you are a little bit more aware of that. Now I will say here, if I have the cubed root of x equal to a negative, that you can have. This would be negative 8 because you could take the cubed root of negative 8 and you would get negative 2. Okay, why would it be negative 2? Because negative 2 times negative 2 times negative 2 gives me negative 8. Okay, but square roots or any even root, you can't have a negative quantity equal to an even root. All right, so find solutions to each of these equations or explain why there is no solution. So now we're going to go and do a little algebra here. Instead of doing it mentally, I'm going to square both sides. So I get a minus 5 equals 25. Add 5 to both sides, so I get a equals 30. Cubed root, I'm going to cube both sides. 5 cubes, 125. Add 5, 130. Cube both sides here. Cube gets rid of the cubed root. Make sure you kind of put parentheses there. And I get negative 8. Now, double check, make sure it works. If I plug this in, cubed root of negative 8 is equal to negative 2. We just did it on the last slide, so checks out. Same thing here. Plug these in. Cubed root of 125, that's equal to 5. Square root of 25 is equal to 5. So now I got to do a little moving around of things, so I'm going to have to take this 2 over here. So here's where you got to be aware of kind of what we did in the warm-up. Square root equal to a negative doesn't work. Square root is denoting that we want the positive root. So this one would be a no solution. Now, you might not have found the no solution when you're doing it on your own. You might have just kept going. You might have said, okay, I'm going to square both sides here, and you get c equals 4. But then if you go to check your answer, you might be able to catch it if you say square root of 4 plus 2 equals 0. You will realize that that is not accurate. So you would probably have to throw it out, and then you'd get to no solution. Okay? Minus 4, minus 4. Cube both sides. So I get 3 minus d equals negative 64. Minus 3. And I get 67. All right, so again, plug it in and check. I think it's going to be negative 4 plus 4 equals 0, which works. So this one's a little trickier. We got square root equal to square root. So you can still do what we were doing, square both sides, and then we lose both radicals. And then I can just add 1, 8 equals x. And I think that was like kind of like the warm up here was this one. We kind of did it mentally, but in case the numbers get too hard for us, we want to have a algebraic process, because you're not going to always be able to do everything kind of in your head mentally. All right, last 2 here. So I square both sides. Now make sure you square the whole side. A lot of times people will write 3y squared, and that's wrong, okay? Because you got to square the 3 and the y, so it should be 9y squared equals 36. So when I get here, what I have is a quadratic equation. So this one, since I don't have a term with a y to the first, I just have a constant and I have a squared term, I can go ahead and use square roots here, and I would get 4 equals y squared, and then I square root both sides. So I get positive and negative 2 equals y. Okay. I would plug them back in and check, though. Square root of 36 equals 3 times 2. 6 equals 6. So the 2 is good. But then here's where you're going to catch an extraneous solution. 6 is not equal to negative 6. So I got to actually throw out the negative 2 and just make it 2. Okay, over here, we're going to cube both sides. Make sure you cube the whole thing. 22 cubed. Ooh, don't know that one off the top of my head. I get 1,648. Z cubed equals 11. Let's divide by 1,648. Let's see here. Does it? Let's just leave it. And then let's cube root both sides. So I'm going to end up getting z equals the cubed root of 11 over, I know the cubed root of 10,648 is 22. So I'm just going to leave it like that as my answer. All right. Now, if you wanted to type it into your calculator and get a decimal, let's see what it would be. If you want to get a decimal, it'd be 0.101. Okay. All right, write an equation that includes a radical symbol with one solution. Let's see, square root of x equals 5. I don't know, let's check. Square both sides, x equals 25. That looks good. No solution. So I'd have to, I guess, let me get rid of that here. So no solutions, you'd have to have a radical equal to a negative. So I'll just make it equal to -5 because this indicates a positive root. So if I plug in a number for x and take square root as a positive value, never going to equal -5. So I guess I shouldn't have circled this 25 here. All right, two solutions with a radical. Let me think on this one here. So what if I said something like x equals radical x plus 1, something like that. So I got to square both sides to get rid of the radical. End up with x squared equals x plus 1. And then I have to move the x over, move the 1 over. And then if you do the quadratic formula, remember the quadratic formula. If you forgot it, here it is. Remember, a is in front of x squared, b is in front of x, c is by itself, it's a constant. So b is -1, so be 1 plus or minus the square root of 1 squared. I'm sorry, -1 squared would be 1 minus 4 times 1 times -1 all over 2 times 1. I think this is going to give me 1 plus or minus the square root of 5 over 2. And then if I want to get decimals, I could. I'll go ahead and do it. 1 plus the square root of 5 divided by 2. So I get 1.62. And then I do 1 minus the square root of 5. I get -0.62. So I do get two solutions. So there's my equation. Let me get rid of these squareds here. Oh, shoot. Rewrite that. All right, switch with the partner and solve their equations. I'm not going to do that part. All right, so what kind of mistakes did you used to make with radical equations that you no longer make? What do you understand now that you didn't? I mean, obviously, this question is going to vary. I would say most people probably, I would say that I used to square both sides before checking if a solution made sense. Like, for example, square root equal to a negative number. Or maybe I didn't check my answers to check if my solution worked. Okay, that would be there. What are some common mistakes that are easy to make with these types of equations? What would you tell someone to avoid these mistakes? I would say it is easy to forget to isolate the radical before squaring both sides. So, if I had something like this, square root of x plus 2 equals 6, I see a lot of people, they try to do this and then they forget to square the 2. That would be no good. You'd have to move the 2 over first, get the radical by itself, and then you can square both sides. Another thing would be, it is easy to forget to check your answer for extraneous solutions. A lot of times with these radicals, you can have solutions that look like they work, but they don't when you plug them back in. So always plug everything back. All right, so our goal, I can solve equations with radicals in them. Hopefully you feel like you met that goal. All right, for our cool down, let's see here. I'll do the first one here for A. I'm going to add 4 to both sides. Square both sides. I get n equals 14. I'm going to plug it back in. Square root of 14 plus 2 is 16. Minus 4 equals 0. 4 minus 4. 0 equals 0. That checks out. Let's go to B. All right, so cubed root is allowed to equal negative. If this cubed wasn't here, we'd be right away. If it was just a square root, we'd be done. We'd say no solution. But cubed roots are allowed to be negative. Cube both sides. There we go. 2, write an equation with a radical in it that has no solution. So I'll come up here for 2. Really, any radical x plus 3, I'll say, equal to a negative. Okay, so that would work. Okay. All right, I hope you enjoyed this video. Thanks for watching.